calculate the PI of AYDG. Okay. This is how many amino acids? 4 amino acids. Okay, 4 amino acids. So we write from N to C. Before I calculate this, or we calculate this together, let's draw it out. Okay, and we don't have to draw it like we do in organic on the exam. We'll just draw it easily. Okay, we don't have to do the, what do they call it, line? Those line sticks or whatever they call it. Okay, let's just draw it out and identify alpha carbon, phi psi, and all that stuff. And then we'll do PI. Okay, so I'm going to draw it in the most acidic form. Okay, so N to C is our convention. So we have the nitrogen, and then what's next? Alpha carbon. And then what's the name of this amino acid? That's correct, alpha hydrogen. Alanine. What's the side chain for alanine?
It's going to be 1 carbon.
Okay, methyl. CH3 is called the methyl group. Now what? It's the C terminus of alanine, but it's formed what type of bond with amino acid Y? What type? What's the name of it? Yeah, but what's the name of the bond between this former peptide bond? This is formerly the carboxylic acid of alanine, right, Jendaya? But now it's formed. What is the name of this bond? Tell it to me like I'm 5 years old. Peptide bond. Okay. So this formerly was the N-alpha amino group of this amino acid, which is tyrosine. So what comes next? Of tyrosine, alpha hydrogen. What's the side chain of tyrosine? Okay, use your flashcards. It's okay. What's next? So this was that former N alpha amino group of tyrosine. We have the alpha carbon. Now what's next? C double bond O, the former C carboxyl end of tyrosine, but it's formed what type of bond with D? Peptide bond with amino acid D. So we have the alpha carbon and the side chain of D. D is called aspartic acid. Since it's fully protonated, I'll do the side chain of aspartic acid. Again, you can use your flashcards. This, what's next now? Okay, the formerly, you're right, Jendaya is right, but this was formerly the alpha carboxylic acid of D, but it's formed a peptide bond, so C double bond O, N, am I right? I just gotta make sure, yeah, okay. And what is this amino acid? Alpha carbon of glycine. And what's the side chain of glycine? Side chain of glycine is just H, correct? Remember? And then COOH. This is not the PI. This is just, I'm just drawing it all out. All right, can we name some things here? Okay, are you comfortable doing this with your flashcards? Okay, good, thank you. I like it when people nod. It's better than this or like this. I get this too now.
Why isn't there like another H with the N for the last amino acid for the glycine here? Like to connect it to the...
This used to be the alpha amino group, but it formed a peptide bond with this.
Okay.
So there's no H. Oh, you're right, you're right. I'm so sorry. Sorry, you're right, I'm wrong. Yeah, peptide bond, yeah. I was wondering, like, yeah. All right, so Can you guys tell me, well, I think you guys know, what's the N terminus here? Okay. What's the C terminus? Okay. Can we label a box or a plane, because it's planar, around the peptide bond? Okay. Here's one. Okay, I'm just drawing it like this because it's trying to designate that it's flat. You see one more? Okay. Anybody see an alpha carbon? How many alpha carbons here? One. Okay. 4 amino acids. How many peptide bonds? 3. What else? Side chains. I think we know what the side chains are. Okay, 1, 2, 3, 4. All right, how about phi and psi? Do you remember what phi and psi are?
Left and right.
So we're going to
Alpha carbon.
take an alpha carbon here. I'll choose one here. I can choose this or this. All right, what's the angle between this alpha carbon and this C double bond O? It's psi. It's psi. Yes, thank you. Okay, if I rotate across psi, this blue peptide bond, I'll label it 2, has an angle that's different from this blue peptide bond. I'll label it 1. So it's an angle between two planes. This is also called torsional angle. And what is psi? Right before. Very good. No, this is phi. Phi. I'm so sorry. Okay, phi. Okay, we'll only concern ourselves with phi and psi. We will not concern ourselves with omega, which I believe omega is this bond. Okay, but don't worry about it. Omega, I believe, is this. But again, like I said, don't sweat it. Okay.
Dr. Anthony?
Yes, sir.
Just for clarity, are there or are there not phi psi's at the N terminus and C terminus, or are they excluded?
I think they're excluded because the very definition, Barry, of a torsional angle is
steric strain phased on from the R groups. Gotcha.
correct. Yeah. So, right. It's a good question. It's an angle between two planes. All right, so something like this on the exam, which is whenever it is now. I forgot the date, the 26th or something. Yes, sir.
So is there only one phi psi for that whole thing?
No, I see a phi and psi here, and I see a phi and psi here.
There's two, okay.
Yeah. Right. Yeah. Phi and psi here, phi and psi here. So this will rotate to the best proper phi and psi angle based on, the strain and the side chain interactions. This will go to the best phi and psi based on side chain interactions, strain, sterics, all that. If you read your textbook, the alpha helix, the I plus 4 alpha helix has phi and psi of minus 57 and minus 60. Oh, I forgot. But they have very good torsional angles for alpha helices, I plus 4. All right, now let's calculate the PI. Okay. So I saw some of this in your homeworks that I was grading, and I gave everyone 10 points. Okay, so, but if you want to do it again, that's fine. But just for your own clarity, okay. This is how I want you to calculate the PI. It's simple, okay. Because do you see the backbone here? The backbone here has no pKa's. What has pKa's? Termini, and then what could potentially have pKa's? The side chains, okay? So because your polypeptide backbone has no pKa's other than your N and C terminus, when we calculate the pi of AYDG, I think it would be easier if you just write it out like this. Okay, what's the side chain here of alanine? What's the side chain of tyrosine? What's the side chain of aspartic acid? And then finally the side chain of the hydrogen. Okay, so now we can use our flashcards to look at the pKa's. So what's the pKa of the alpha amino group of alanine? 9. It's got to be 9 something. 9.87. Okay. Anything else you see have a pKa? What about the C alpha carboxylic acid group of glycine? 2 something. What is it? 2.24? 2.35. Very good. And side chains, anybody see anything here? I think this one. And that one. This is about 4, right? The side chain of aspartic acid. It's got to be 4. 4 something, though. I don't know. I don't know the other digits. I just know 4.
3.90.
3.90? Oh, I thought it was 4. Okay. And then the side chain of tyrosine, it's got to be 10 something.
The side chain, 10.46.
10.46. All right. So we're calculating the PI. We drew the structure and we labeled some parts and we got everything. Okay, are we ready to calculate the PI now? Okay, let's go ahead and calculate this PI. What's the first proton to go and at what pH? Right, 2.35. At a pH 2.35, we have 50-50 of form 1 and form 2. So we start getting this appearance. Okay, I'm going to call this form 2. Okay. Okay, so at pH 2.35, how much of 1 and 2 do we have? 50% of each, okay? All right, now let me ask you this. What's the total charge here? Plus 1. What's the total charge here? Wait, oops. Boy, you got to be very careful. Okay, this is very dangerous. Okay, I forgot the plus 1 here. Now what's the charge? 0. Okay, there's a special name for that. What do we call it? We call it the Zwitter ion. All right, we're going to move on, even though we have the Zuider ion. We're going to move on. What's the next one to come off? 3.90. Okay. At a pH of 3.90. 3.90, this begins to come off. Okay, and now we have a third form. This is form 3. Okay, and what's the charge here of form 3? Okay, it's going to be -1. I'm going to move on. I know a lot of us in previous classes as well, I'm going to average these two and get the PI, but I'm going to go all the way, okay? I'm going to get this one and this one, okay? So what's the next to come off? The 9.87. Just be careful here. Okay, you can make a lot, and this is me, you can make a lot of transcription errors here, so just be careful. 9.87, see? It's just like that. Okay. Okay, so now we have form 4. Okay, what comes off at form 4? I think you mentioned this, the alpha amino group. Okay, so that's NH3 plus becomes NH2 at 9.87. And then finally, what's the last one to come off? Okay, this one. And the charge, what's the total charge of form 4? Okay, and now we'll do our final one here. And this is pH 10.46. And this is going to be like this. Alright, and this is form 5, and what is its total charge? -3. Okay, so there's actually 5 forms of this tetrapeptide. Tetrapeptide, it's AYDG. And a couple of things here. What is the PI? It is by definition. Okay, by definition, the PI is the pH where what dominates? Zero charge dominates. So the PI is the pH where the Zuider ion dominates. So that's going to be the average of these. See, at form 2, 50% is the Zuider, and then that. At pH 3.9, 50% is the Zuider, and then the rest is the other version. So we're going to take 2.35 plus 3.90, and we're going to divide it by 2. And what do we get when we do that? About 6.25. So at a pH of 6.25, this is the most populous.
Then you divide it.
I did divide it by 2, didn't I?
You didn't divide it yet.
Yeah.
Yes, you're right. 3.13. Okay, there you go. Thank you. So at pH 3.13, this is the most dominant. Okay, so this is the answer. Okay, so I think I got a lot of 6s or 6.1s or whatever, but you need to take the average. So, right, so if you got 3.13 and you did your homework, okay, very good. That's excellent. But make sure you do it like this, okay, for the one that's in the homework. Okay, so I gave everyone the points, but more importantly, that's not important. That homework, what's important is you get it right and you get it right for the exam. Okay, so that was just practice. Same thing like this also you'll see on the test. Okay. Right, what form of AYDG is dominant at physiologic pH 7.2? What do you think? At 7.2, this is still protonated. This is off. This is off. At pH at 7.2, I would form 3. Form 3 would be the most populous form. Yeah. So the -1 will be most populated in our cells if this were floating around in our cells with a pH of 7.2. All right, so if you didn't get that PI problem, like I said, I was grading homeworks, and some of you got it right, some of you forgot to divide by 2, and some of you, I think it was you, Courtney. I'm not trying to pick on you, but you drew it all out. You drew all the atoms out. You can just draw it like this. Okay. 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 You can draw it out like this because the backbone does not have any pKa's. Just the N terminus and the C terminus have their. All right. Any questions? Okay. So make sure you're confident and good enough to do it, at least for the exam.